mass is 3m. So when it has come to this place, it has a total mass of 3m, which is broken into 3 equal parts, m, m, and n. It has given that first fragment retraces its path. That means it is going back. It retraces its path. And the second fragment moves vertically upward with a speed of 3 v naught by 2. We are required to find out the speed of the third fragment. We have to required to find out the speed of the third fragment. Actually, what is happening over here? So, if the explosion is taking place, it is because of the internal force, right? So, no external force is involved in this process. So, we say that the net momentum of the system should remain constant. So, we can write P initial is equal to P final. So, I'm going to write here that P initial is equal to 3m, and it was moving with v naught cos 60, that is v naught by 2. And let me write down the direction. It is v naught by 2 I cap. So this is v naught by 2 I cap. Always remember that this kind of question while solving, always put the direction. So it will be easy for us to get the direction of the final value also. So now it is giving that one of it is retracing its path back. So that means let it be this m is going back. So it's moving with minus of m and with the same velocity v naught by 2, but in the backward direction it is minus I cap. Actually minus I put it here. And one is moving in the upward direction, one part is moving in the upward direction. So it is moving in the j cap direction with the speed of 3 v naught by 2. So velocity will become 3 v naught by 2 j cap. So we can write it as m into 3 v naught by 2 j cap plus m v. We don't know what is this value that we want to find out. You can see that this m and m are all getting cancelled out. v naught and v naught are gone. So finally we are going to get it as v is equal to minus of 4 v naught by 2 I cap minus 3 v naught by 2 j cap, right? So final answer is coming as we are required to find out the speed of the third segment. Speed is nothing but the square root of this one is minus 2v naught whole square, that is 4v naught square, plus 3 by 2 is 1.5 square, or we can directly write it as 9 by 4 v naught square. V naught square will come out, and this one is 16 plus 9, that is 25. Square root of 25 is 5 divided by 2. Square root of 4 is equal to 2. So finally we are going to get the answer as 5 v naught by 2 is the correct answer. That is option B. Let's move to the next one, 33. The particle is moving with a velocity of 1 by 10th of the light. 1 by 10th of that of light will cross a nucleus in about. So first of all, we have to assume that what should be the, it is crossing a nucleus. Actually it is given it is crushing a nucleus. But I am taking that the radius of the nucleus is 10 to the power in the range of 10 to the power minus 15 meters. 10 to the power minus 15 meters. So if it wants to crush the nucleus, so it has to traverse its diameter. So the total distance covered by it is going to be 2 into 10 to the power minus 15 meter, 2 into 10 to the power minus 15 meter, and the speed is coming as 3 into 1/10 of the speed of light. So B equal to C by 10. C is 3 into 10 to the power 8 minus 1, that is 3 into 10 to the power 7 meter per second. So we can write the speed is equal to 3 into 10 to the power 7 meter per second. So how to find out the time period? Time period is 2t divided by v. So it will be 4 into 10 to the power minus 15 divided by the speed, that is 3 into 10 to the power 7. So we'll find it out. Finally we are getting it as like, it's in the order of like 1.33. It's around not 2 actually, 2d, no? 2d is like, it is radius. Radius is, it's totally d by b, sorry. So it is 2 by 3 into 10 to the power 22 plus 22, and minus 15 minus 7 is minus 22. So it is in the range of 10 to the power minus 21 second. It is in the range of 10 to the power minus 21 second. About it is answer. 34. It is given that when a hydrogen atom emits a photon in going transition from n equal to 5 to n equal to 1, It is given that there is a hydrogen atom which is emitting photon and it is going a transition from n equal to 5 to n equal to 1. It is coming down actually. Its recoil speed is almost how much? We are required to find it out. Okay, so let's understand it. We know that here in this case, while finding out the recoiling speed. Okay, let's first find out what is the value of 1 by lambda here. 1 by lambda, because as we know that momentum is equal to h by lambda. This is your momentum, right? So how to find out lambda? We have the formula, you know already. I am writing down this formula once again. 1 by lambda is box formula r z square into 1 by n1 square minus 1 by n2 square, right? Clear? So here we can put all these values to get the value as 1 by lambda, and this is hydrogen, so z square will become 1, r into 1 by 1 minus 1 by 5, right? So it is coming as 24r by 25. So this is the value of 1 by lambda. We are equal to find out P is equal to h by lambda is equal to 24 RH divided by 25. And this one is given. This is coming as after putting all these values. So we'll be getting 6.9 into 10 to the power minus 27. 6.9 into 10 to the power minus 27 kg meter per second. We are equal to find out the speed of the particle or recoiling speed is momentum by mass. Momentum by mass. So mass of one hydrogen atom is coming, a photon is 1.6 into 10 to the power minus 27 kg. Just put it this value. We'll be getting almost the answer is equal to 4 meter per second. 35. Consider the nuclear reaction. We are required to find out this question is on the energy released in the reaction. This question is on the energy released on the reaction. So let's do it. Okay, so how to find it out? You know that first of all we have to find out the binding energy, but here it is given binding energy per nuclear. So binding energy of X, binding energy of A, and binding energy of B. So let's first find out the binding energy of X, that is 200 into 7.4, because per nucleon it is given, so 200 into 7.4 MeV. So this similarly, this one is coming as 110 into 8.2 MeV, right? 110 into 8.2 MeV, and the binding energy of B is coming as 80 into 8.1 MeV, right? So this is coming as 648. 110 into 8.2. 110 into 8.2 is 902 MeV, and 200 into 7.4 is coming as 1480 MeV. We are required to find out the energy released in the reaction. So how much is the energy released in the reaction? So where are the two products, that is A and B? So we are going to add the energy of these two, that is 902 plus 902 plus 648 minus 1480, right? So this one is 1550 minus 1480. So final answer is coming as 70 MeV, right? So this is the answer to the question. 36, very easy. When photons of energy h nu are incident on the surface of photosensitive material of work function h nu naught. Work function is not going to be changed, right? But we are going to use the photoelectric equation that half mv max square, that is the maximum kinetic energy, is equal to the amount of energy that is falling on the surface of the metal minus work function. Minus one function, that is coming as h into nu minus nu naught, right? So this is called as Einstein's equation of photoelectric effect. So your final answer is option C. So the kinetic energy of all the first emitted electron is coming out to be this much. Clear? Kinetic energy. If it is velocity, then we can write it as 2 times of this one divided by m square root of this. We wish to observe an object which is 2.5 angstrom in size. If we want to observe an object of any particular size, we are required to find out the minimum energy photon that can be used. You know that scattering should take place. Scattering should take place. For a scattering to occur, the wavelength of the waves that are falling on it must be of the same order of the magnitude of smaller than the size of the object. We can write down the lambda that is falling on it must be of same order. It must be of same order of magnitude or smaller than the size of the object. Smaller than the size of the object. Clear? That is being observed. So let's find out that the largest possible wavelength then the largest possible wavelength should be equal to the size of the object, that is 2.5 angstrom. We are required to find out the minimum energy. As we know that minimum energy corresponds to maximum wavelength. So that is hc by lambda max. So hc value, you can directly put it value in terms of your electron volt. It is 12.40 into 10 to the power 3, or we can write 12431 electron volt angstrom divided by 2.5 angstrom. Right, 2.5 angstrom, that is 5 kilo electron volt. (38) Boolean algebra. Following circuit is equivalent to which one? Right? What should be the equivalence of the circuit? As you know that this one is A. So here I am going to get it as, this is a NOT gate, so we will be getting A bar. This is B bar. So they both are going to be passed by this. So we are going to get here A dot B whole bar. A dot B whole bar. And as per the Boolean algebra, we know that if such type of equation will come, we get it as A plus B. Whose equation is this? This is for OR gate. And another question is also kept on this. The same on the Boolean algebra. If you don't know, so this is the final expression as per your equation. So the next question is question number 39. In a transistor, as we know that emitter is going to be highly doped, and then the collector is moderately doped and the base is least doped. So direct answer is option A. Emitter is more highly doped than the collector. Emitter is more highly doped than the collector. Option A is the correct answer. Question number 40. We have to check that the what is the, whether this is higher forward biased or reverse biased, this ideal diode. Can you see this is 2 volt? This one is a lower potential and this is connected to higher potential. Can you see that? So this end is connected to the lower potential and this is higher potential. So in that case, it acts as an open switch, the diode. So that means no current will flow. Answer is equal to 0 because this is reverse biased. (41) Again, we are going to find it out by De Morgan's theorem, the final result by using De Morgan's. Then after that, we are going to plot it in the graph. So can we see that this one is A, so here it will be A bar, this is B bar. So finally, when it will come out, it is going to be A bar plus B bar, right, whole bar. So according to De Morgan's, we will be getting A dot B, exactly reverse of the previous situation of question number 39, right? A dot B. So now we are going to use the truth table. So if we use the truth table, we know that if I'm going to put the value of AB and A dot B, so A is 0, B is 0, 0 and 1, 1 and 0, and 1, 1, 1. A dot B is 0, and this is also 0, 0 and 1, right? So that means we can see that if both of them are high, so output is going to be high, right? If both of them are high, so the output is going to be high. So which situation is this? You can see that the first situation is both are high, so here we are getting the answer as high. So these are same. So this situation is also going to give us the correct result. So answer is option A actually. But I will show you the other options as well. See what are the difference of the other options and this option. You can see here, even though they both initially both are high, so in all this situation except C we can remove for this basis. And here also for the other situation we are seeing that there are two highs are there, so we can remove all these conditions except condition 1. 42. A piece of glass is placed on a paper having letters of different colors. The letters of which color is going to be mostly raised? We know that the raising of height or the raise of an object depends on, or we can write the raise of an object is equal to actual height into 1 minus 1 by mu, right? So we know that for the raise to be maximum, if we want the raise to be maximum, mu has to be minimum, right? Mu has to be minimum. So mu is inversely proportional to lambda, as we already know that from Cauchy's formula. Mu is inversely proportional to lambda, right? So whose wavelength is least? Violet. So violet is the answer. Violet is the answer. (43) Refractive angle of a prism is 60° and the minimum deviation we have is 30°. We are required to find out the angle of incidence. Direct formula we have, right? Right? Put everything inside. So this is given as 30°. 2 into I minus 60 prism angle. So 2i is equal to 90° and I is equal to 45°. I is equal to 45°. 44. The correct relationship between the angle of diffraction phi and the glancing angle theta in the Davison-Jaumer experiment. He was a German physicist, so he made an experiment. So the experiment is very simple actually. It's just like this. You already know the glancing angle, right? Glancing angle is theta and the angle of diffraction is given as phi, right? Angle of diffraction is given as phi. Actually, this one is given as angle of diffraction and these are the glancing angle of theta. As we know that all these three angles are going to give you a sum of 180°. So we can write 2 theta plus phi equal to 180°. So we are required to find out the value of theta. So 2 theta equal to 180 minus phi. So theta is equal to 180 minus phi by 2. So it's coming as 90 minus 5 by 2. 180 by 2 is 90 minus 5 by 2. So it is, answer is option A. Answer is option A. (45) Last one on Young's double slit experiment. The maximum intensity in Young's double slit experiment is I naught. The distance between the slit is given. Okay, so I'm going to take it as the two slits S1 and S2, and the distance between the slit is given as D. And the screen is placed exactly at a distance of, it is given that the distance between the slit and the screen is 5 lambda, right? Sorry, D equal to 5 lambda. This capital D is 10D, which amounts to be 10 into 5 lambda, that is 50 lambda, right? So just in front of it, we are going to put a point that is A, and this point is going to be B, right? So it is exactly at the middle, we can see that. We are required to find out the intensity of the light in front of one of the slit. Here we wish to find out the intensity of light. We know that if you know the maximum intensity, how to find out the intensity of light at any particular point, that is I equal to I max or square phi by 2. What is phi? Phi is phase difference. Phi is phase difference. So let's find out the path difference now. What is the path difference? How do you calculate the path difference? Path difference del x is calculated as y small d by capital D, right? So we can write del x is equal to y is d by 2. Y is equal to d by 2 because this one is d means this is going to be d by 2, which is the distance from the central maxima. It is d by 2 into d divided by 10. D are gone, so we are getting it as d by 20, right? D by 20. Okay, if I wish to write it in the form of lambda, so it is going to be 5 lambda by 20 is equal to lambda by 4. Let me find out the del phi, which is equal to phi, phase difference, 2 pi by lambda del x. So here it is coming out to be 2 pi by lambda into lambda by 4. Lambda and lambda are gone. So we are going to get it as pi by 2. So this is your phase difference, that is pi by 2. So let me write down all these things. I is equal to I max is I naught cos square pi by 2, that means cos 90. Oh, sorry. Cos square pi by 2, no? Pi by 2, right? Pi by 4, right? Cos 45 degree is 1 by root 2 and 1 by root 2 whole square is 1 by 2. So we are getting to get it as I naught by 2. So what is the answer? Answer is option A. Answer is option A, that is I naught by 2. So with this we are done with the paper. Thank you everyone.